In this video, we will be discussing vectors and how vectors are used in physics. Now, a vector is any quantity in physics that has both magnitude and direction. Typically, vectors are going to be illustrated by drawing an arrow above the symbol, and the arrow will be used to convey the direction and the magnitude. So vectors are used when we require a magnitude and a direction for a complete description of the behavior of a substance. For example, force, velocity, or acceleration, electric field strength, each of these cannot be completely described in terms of magnitude alone, but would need direction and therefore would be vector quantities. Now on this page I place some key formulas that will be used with vectors when we use trigonomic values. And so as we continue forward on the videos and you need to see where did these formulas come from, refer back to this slide. Let's begin with vector addition. If we have two similar vectors pointing in the same direction, we can add them up. The example we will look at is a man walks 54.5 meters east and then another 30 meters east. So we would calculate his displacement. So the first vector we have is 54.5 meters and it's east, and then he walked 30 meters east, and because they are in the same direction, we add these up and we would get a total displacement of 84.5 meters. Notice that the size of the arrow conveys the magnitude, and the way it was drawn will convey the direction that the object or the individual is moving. Now here we will look at vector subtraction. So if we have two vectors and they're going in opposite directions, we subtract. The example that we will look at will be a man walks 54.5 meters east and then 30 meters west. So we will calculate his displacement. So we have a longer arrow indicating that he's walking 54.5 meters east, and that's further. We have the shorter arrow showing that he's walking 30 meters west, and what we do is we subtract the difference and we get a displacement of 24.5 meters east. Okay, but what if we have two vectors that are perpendicular to one another? How do we solve these? For example, we have a man that walks 95 kilometers east and then walks 55 kilometers north. We want to calculate his displacement, and so we need to calculate this area right here. Now this is called the resultant, and to calculate the resultant we will use the Pythagorean theorem. The Pythagorean theorem is c squared equals a squared plus b squared. Or we can simplify it into c equals the square root of a squared plus b squared. So this right here will represent my a squared, this will represent my b squared, and so we're going to plug these in, and so this would be our c, and so we would get c equals 95 squared plus 55 squared. We solve, and we would get our displacement as 109.8 kilometers. But what about the direction? In the previous example of displacement was asked, since it was a vector, we should also include a direction. And so one of the things I want you to know is that when we're drawing a right triangle that conveys some type of motion, we have to draw in a way that we draw head to toe, so that our motion would be from here's the head, and it would attach to the toe here, and that would give us our triangle for us to find the resultant. And so next we must find what direction did our man move. Was it north of west? Was it west of north? East of north? And so that's what we need to do next, is to determine the direction. But just putting north of east or west of north or such on an answer is not specific enough for a direction. We must find the value of the angle as well. So to find the value of the angle, we will go back to slide number 2 and we'll use the trigonomic function called tangent. And when we look at that formula, our tangent equals our opposite over our adjacent. And here we have the opposite is 55, we have the adjacent is 95, and we get 0.5789. And so we will take the, if you see this -1 right there, this means inverse. So we'll take the inverse of the tangent, or on your calculator, second tangent, and put in our answer here, our 0.5789, and we will get our angle of 30 degrees. And so the complete answer for our previous problem was 109.8 kilometers, 30 degrees north of east. Now let's look at another example. What if we're missing the components and we just have the magnitude and the direction? So suppose we have a person that walks 65 meters, 25 degrees east of north, and we want to find out what were the horizontal and the vertical components. And so what we're going to do is we're going to draw this out as our 65 meters, and this was 25 degrees, and our goal is to make a right triangle. So as we've drawn this out, you can see that we have this right here as one side of our right triangle, and then right across there is our other, and you can see that we made a right triangle right there. And so we want to find our components. Well, to solve for the components, we're going to use the trigonomic functions of sine and cosine. And you'll find these formulas on slide number 2. But here we have our cosine for our angle is the adjacent side divided by the hypotenuse side. And here we have our sine of the angle equals our opposite side divided by the hypotenuse. And so if we want to find our adjacent and our opposite, we can rework these two formulas so that we get the adjacent equals the hypotenuse times the cosine of the angle, and our opposite will equal the hypotenuse times the sine of the angle. So the way this works is this right here is our hypotenuse, and so our adjacent we would have 65 cosine of 25, and then we got that right here, and so that we would have our adjacent as being 58.91. And then to find our opposite, we would come over and we would have 65 times the sine of 25, and we get 27.47 meters east. This one would be of north. And so this right here is our 58.91 meters north. This right here would be our 27.47 meters east. Let's look at another example. A bear searching for food wanders 35 meters east and then 20 meters north. Frustrated, he wanders another 12 meters west and another 6 meters south. Calculate the bear's displacement. Well, we've mapped it out right across here. He went 35 meters east, 20 meters north, 12 meters west, and 6 meters south. And so this would be very difficult to draw out a right triangle, but let's take it in components. He went 35 meters east and 12 meters west. And if we draw this right here and we do our subtraction, 35 minus 12, we get that the bear moved 23 meters east. Again, the bear went 20 meters north and then 6 meters south. We represent this here. And so if we do our subtraction, the 20 minus 6, we get 14 meters north. Now that we have these components, let's go ahead and draw out our triangle so that he went 23 meters east, 14 meters north. We connect this right here. Here we have our resultant, which is our hypotenuse. We're going to use the Pythagorean theorem. Remember that c equals the square root of a squared plus b squared. So we will get the resultant right here as being 14 squared plus 23 squared. We get 26.93 meters. Now we also need to determine his angle. So we will use our tangent. And when we do our tangent, we take our opposite divided by our adjacent, and we get 0.6087 because we had the 14 divided by 23. Again, to get the angle, we will take the inverse of the tangent or the second tangent. So we would hit second tangent 0.06087. We would get an angle of 31.3. So our final answer would be the bear moved 26.93 meters, 31.3 degrees north of east. Now here I've placed an example problem for you to try just to make sure you understand what we've done so far. The solution is on the next slide, so if you want to pause, you can pause here, try to work out the problem, and then you can check your solution on the next slide. So hopefully you were able to solve the problem, but let's just review over the solution. The boat moves at a velocity of 15 meters per second north and then drifts 8.5 meters per second west. So we draw that out, and then we make our triangle. We have a right angle here. Here we have our resultant. Here we have our unknown angle. And so to solve for the resultant, we will take the square root of our a squared plus b squared. So we have the square root of 8 squared plus 15 squared. We get 17 meters per second for our resultant. To find our angle, we will use the tangent of the opposite divided by the adjacent. We get 0.5333. To get this angle, we will take the second tangent of 0.5333 and we get an angle of 28.1. So that our final answer would be 17 meters per second at an angle of 28.1 degrees west of north. Here we have one more example problem. You can pause the video, attempt to work out the solution for this example, and then look at the solution on the next slide. This way you can ensure that you understand what we've covered so far. So let's look at the solution for our problem. Now what we notice is that the plane moves 63.5 meters per second, and it's at an angle of 32 degrees south of east. We want to calculate the horizontal and the vertical components. Now we have these formulas right here that we can use, and we had these from slide number 2. We're going to rework these. Because we're looking to find the horizontal component and we're trying to find the vertical components, what we can do is we can find these by readjusting. Our adjacent will equal our hypotenuse times the cosine, and so in this way we can find this area right here, and then on this one we can have the opposite will equal the hypotenuse times the sine, and that's going to give us this area right here. So let's plug in our numbers. So for the adjacent we're going to have 63.5 times the cosine of 32. We get 53.85 meters south. And that goes right here. Now to find our vertical component, we'll have 63.5 times the sine of 32, and we get 33.64 meters south. And that would be that component right there. Okay, here we have one additional example problem. A storm system moves 5,000 kilometers due east and then shifts course at 40 degrees north of east for 1,500 kilometers. Calculate the storm's resultant displacement. Sounds a little confusing, but first off what we're going to do is we're going to draw that 5,000 kilometers, and then right here we're going to make it 1,500 kilometers, and this right here is our angle. And so we're going to ignore this section here, and we're going to find our horizontal and our vertical components just like we've done in our previous examples. So we have our cosine and our sine formulas. We have the adjacent will equal the hypotenuse times the cosine of the angle, and our opposite will equal the hypotenuse times the sine of the angle, just like we've done previously. So that our adjacent, this right here, would equal our 1500 times the cosine of 40, and so we would get this area right here as being 1149.1 kilometers east. And then to find this one right here, we're going to use the opposite equals 1500 times the sine of 40, or we get 964.2 kilometers north. Now what we're wanting to do is find this long resultant here. So we're going to draw out our new triangle. And so if I was to take this right here, this 1149.1, which is this area here, and I was to add this up to the 5,000 kilometers it moved, I would get that total distance that the storm cell moved. And so I would end up with 6,149.1, and that's what we're going to have right across here. Now we calculated this area here as being 964.2. That's what we've got here. We draw this across, and now we need to solve for our resultant. And we're going to do this just like we did on our previous problems. Our resultant will equal the square root of our a squared plus our b squared. So we plug that in, and so we get our resultant as being 6,224.14 kilometers. We need to find our angle. So again, with our angle, we're going to use our tangent, and we're going to do our opposite divided by our adjacent. So our tangent would equal our opposite divided by adjacent. We get our number right here, and then we're going to take our inverse tangent, or our second tangent, and we get our angle of 8.91. And so our final answer would be 6,224.14 kilometers at an angle of 8.91 degrees north of east. One additional thing that I want to make note of, and that's this area right here. That number's wrong. What should be in that place is 0.157. So this right here was a mistake, and if we took the 964.2 divided by 6149.1, we get 0.157. We take the inverse tangent or second tangent of 0.157, and that's where we get this 8.91 for our angle.